Hello everyone, I'm Xavier. In this video, you will know everything you need to know about Git as a beginner. I will tell you what functions Git has and practice using them together with you. But before telling all the details about Git, let's first understand what Git is and how can it help us. Let me use a common example to demonstrate it. Let's say we have a project. It may be a web page development project, or a C++ software, or a simple Python program. There may be one or several files contained in the project. One day, we want to add a new feature to this project. It may only affect several lines in a file, but sometimes we may need to completely rewrite the program. It's fine if we do everything right in one try, but if for whatever reason we failed in the end, there will be a problem recovering the project to the good old version. A common way to do that is to back up the project folder before changing the files. But it's very easy to lose track of so many backups and get confused. With Git, backups are created easily with all the information that will be useful in the future. Moreover, it saves a lot of storage space since Git compresses all the backups in a very efficient way. Apart from that, like any big companies, we usually need to work with others as a team. Let's say we want to create an NFT website platform. The project may be divided into different parts, and usually people need to change the same files at the same time. A common way to do this is to use shared documents, like a Google Doc. But if we want to test the code, you may need to wait until everyone finishes, which is very inefficient. Git allows users to change the files on their own computers without internet, then later help with merging the different versions of project that are created by a different person. Moreover, Git allows multiple versions of the project exist at the same time as different branches. It can not only make teamwork easier, but also allow access to multiple versions at the same time, like WhatsApp has versions for phone and computer, or TypoRust has stable versions and beta test versions. Now, I will introduce some basic concepts in Git. In Git, there are mainly three spaces: the working directory, staging area, and repository. Working directory is mainly the folder of the project stored in your local machine. It is also called working tree in Git. Repository is where Git stores all your backups or snapshots of your project and other useful informations. As for the staging area in the middle, it is also called index in Git. This is believed to be one of the best features in Git comparing to other version control systems. So in Git, when you make some changes in the working directory, before submitting it directly to your repository, it will be first staged to the staging area. And here you can see all the changes you have made and choose which changes to keep and which changes to discard. And finally, you can commit these carefully chosen changes to your repository. Save it as a backup. Later, you will see how this feature benefits our working process. Now, I will talk about some Git commands. First, if you want to create a new repository of Git, there are mainly two ways: turn an existing folder into a Git repository, or clone an existing Git repository, remotely or locally. So to turn an existing folder into Git repository, you need to first download Git and navigate to the folder where you want to create the repository. Here it is demo space folder. By typing git init, you will see this prompt. And in the folder, you can see a new folder called .git. By default, this folder is hidden by the operating system. And if you enter it, there are several files that we don't need to understand now. However, if you want to create a new folder, as well as initialize the Git repository there is another way. We call git init and the folder name. For example, new project. And now you can see that a new folder will be created, and within that there is a .git folder. which means that this folder is now a Git repository. The second way is to clone an existing repository using the URL of the repository. For URL, there are three main choices: SSH, Git, or HTTP. The example formats are listed here. Now, I will use an GitHub repository as an example. So here is a public repository. I will use the SSH link of this repository to clone it. By typing git clone and the repository URL, enter, you will clone the repository to your current working directory. In this case, the daemonspace folder. You can find a new folder here, which is Raspberry Pi. So, what should we do in order to make changes to the repositories and saving the changes? Git add function is used to tell Git start tracking some files, and also add the changes happened to these files to the staging area. Git commit is used to save the changes happened to the files from the staging area to the repository. I will show you how this works. I will still use the daemonspace folder as an example. But before that, let me clean up the environment. If you want to delete a Git repository, you only need to delete the .git folder. But here I want to clean up everything. So delete them all. And I want to reinitialize it by calling git init. Now I'm creating a new Git repository. And I'll create a new file. And now, this file is in the working directory. By calling git add file.txt, I'm adding the changes to this file to the staging area. And finally, if I want to save the changes from staging area to the repository, I call git commit. Since my default editor is VS Code, Git will jump to the VS Code. And I'm required to add some note message describing this commit. Close it. Success. Now, the changes I have made is saved into the repository. For git add, instead of typing the file or folder name, I can also use a pattern. For example, now I add two more files. If I want to add these two files at the same time, I can do git add, or I can just do this. You may ignore these warnings. It's what Git does to the Windows line ending system. For git commit, instead of waiting for Git to open the default editors for ourselves, we can also use the -m and add the message directly. For example, git commit -m add note.md and readme.md. And it worked. For the commit message, there are several standards that are generally used. For the first line, describe what you did in one sentence, and leave the second line as blank. For the remaining lines, describe why the changes you made is good. So what if you want to directly save the changes in your working directory to the repository and skip the stage step? You can use -a to do this. And if you don't want to add a new commit, you can use -amend parameter to save the changes to the last commit. But during the developing process, we may easily lose track of how many changes we have done and whether we have saved them and where we saved them. Git status and git list files can be used to track the intermediate statement of the Git repository. By calling git status, it will show the summary of the Git repository to us. I will start with a new repository, so I will delete everything here. By calling git init, I'm initializing the repository. And now let's see the status of the repository. There are three sections. In the first line, it shows which branch we're at. By default, the default branch is called master. I'll talk more about the branch later. And the second section shows how many commits we have done. And the third section shows how many changes haven't been added to commit yet. Because it's a new repository, of course, it's all empty. So how about I create a new file? Now let's see how it works. We can say that the first two sections are the same, but for the third section, it lists all the untracked files, because Git by default won't track any files in the repository, only after you git add it. So to start tracking this file, I call git add file1.txt. And now let's say it again. It becomes green, and it says the changes to be committed. This means that the changes has been added to the staging area. What if now I commit it? Now let's see again. It says nothing to commit, working tree clean, because all the changes in the working tree has been added to the repository already. So what will happen if now I call git list files? It shows file1.txt. So even though we have already staged the changes of file1.txt to the staging area, and then save these changes to the repository, the file1.txt is still left a copy in the staging area. And what if I add a new file? Git status shows that we have a new untracked files. And file1 is not shown here because it already been committed to the repository. Now what if I call list files? It still shows file1.txt because we haven't added file2.txt. Now I add it and say again. It's been added to the staging area, and list files also shows file2.txt. So what if we decided to rename or remove some files? Git also provides a lot of useful commands for such actions. For example, git mv allows to rename a file, and git rm allows to delete a file from the working tree as well as untrack it from the Git repository. You can also just use the normal non-git commands like rm or mv and then use git add to do such things. Let's see how it works. So after what we have done in the last section, let's see the repository status. We can say that file1 has already been committed to the repository, and file2 is just newly staged to the staging area and hasn't been committed. So let's just commit it first. Now, if we want to rename a file, for example, I want to rename file1. And let's see whether the changes has been updated. Git shows that it is renamed. And let's try to remove file2. Success. Now if you see the working tree, file2 has also been removed. If you want to remove a folder, you can just use the -R option to remove the folder and the files inside recursively. Git also provides --cache option to remove the file only from the staging area instead of working tree. So if you call git rm-cache, you will still have the file in your working tree, but it will be no longer in the staging area, which means Git has untracked this file. We can also use some non-git commands like rm mv without git in the front, and also plus git add to do the same thing. but with some extra steps. For example, now I want to rename the secret.txt file. I can use non-git commands like mv. Now we can see that the file is renamed as file1.txt. Let's see the status of the git. It detects two things. First, secret.txt is deleted. And second, file1.txt, the new renamed file, is in the untracked status. We can finish this step by calling git add. However, now we need to include both file names. Now let's see the status. Now git detected as the rename command. Finally, let's commit. A success. For the remove command, it's similar. For example, I remove it from the working tree. And let's see the status. It detected as a deleted file. And now I call git add. It is staged to the staging area. And finally, we commit it. Success. So sometimes we want to always ignore the changes in some type of files. So how to do that? Git provides a feature called quick-ignore. So it's really simple. We just create a file called .gitignore, and we add the file names or the folder names or the patterns inside this file. And all the names listed in here will be ignored by Git. It will never be tracked. So how to do that? Let's say I have a new repository, and I'll create some files. So now we have these 4 files, and let's check the status. It detected 4 untracked files. And now I want to ignore the bin file because it's binary file and maybe really large. It's not good to check it. So to do that, I just add a new file and type this name inside the file. And now let's run the status again. We can find that ignore is shown up here and bin has disappeared. And let's check the information here. See, the file name is listed here. And we can also use patterns inside. For example, add a txt inside it. And now let's check the status again. You can see that all the txt files are disappeared. This is how it works. And don't forget to commit your changes. So if I want to check the history of a repository, we can use git log, which will show all the commits. For example, I clone an online repository. And get into it. Because there has already been a lot of commits there, so I just run git log. You can see that it printed all the commits history. So here, this is a unique ID of each commit, and head, it shows in the .git file. It's here. And this is actually a pointer, points to a Git repository object. So what is object in Git? A commit, a file, a folder, they are all objects. For details, you can search online. And here is the author and date information. And here is the commit notes. If you think this is too wordy, there are more options for you to use. For example, git log one line. It shows all the history in one line. This is a shortened unique ID. This is a pointer. It points to the main branch now. And this is a history note. And you can also use the reverse option. It shows the oldest changes first. So this is the initial commit, and the newest commit is here. If you want to see more, if there are too many, you can press enter to show more, or you can press Q to quit at any time. You're welcome to press .h for more information. And if we want to view the changes between two commits or two branches, we can use git diff to say the working directory and staging area difference, or staging area log git repository difference, or working directory and git repository difference. Or we can even check the difference between arbitrary commits. Let me show you how. So now if I run git diff, there will be empty because I haven't made any changes now, as you can see here. So what if I add some file? Now you can see untracked file. If I run the diff command now, you can see no change because it shows the difference of the content of a specific file. So now I git add temp, and if I run it, still no change. But if I add more information in this file, and now I run git diff, now you can see some information are tapped out. So for the first line, it shows that what files are used to compare. So actually here we're comparing two versions of TMP file. For the second line, it's some metadata that we don't need to care. And the third and fourth line shows the marks used for each file. For minus mark, it is used to mark the first version of a temp file. Plus, it is used to mark the second version of temp file. This blue line shows two informations: the starting line number and how many lines are extracted here. For example, for this file, it starts from line number 1. And for this file, it starts from line number 1 and 2 lines are extracted here. We can also use --stage or --cached, comparing the staging area and git repository difference. For example, git diff staged. So we can see the similar format, and because in the repository there's no record, so it shows the depth now, and also it starts from line 0 and has 0 lines of contents. But for the staging area, there is 1 line, which is test. We can also compare the working directory with the git repository. To do that, we call git diff and head. Head is the pointer of git. Currently, it points at the main branch. So it's in a similar format. And there are 2 lines in the working directory compared to the git repository. Moreover, we can also check the difference between arbitrary commits. For example, if I call git log -1 line, and we want to compare in these 2 commits. To do that, we call git diff and copy the ID here. Now it will show all the changes made. Because there are multiple lines, so we need to tap enter to show everything. Because there are multiple files has been changed, so there will be multiple sections shown here. I'll press Q to quit it. If you don't want to compare 2 specific objects, we can also use git show to show the detail of a specific commit or some object. We can also use the pointer to specify, for example, header and add a number here to specify which commit we want to see. Or we just use the object ID. If we want to see the specific content of a specific file, we can use the common file name without any space in between to show the details. We can also add 2 objects and show the details of all the commits in between. Let me show you how it works. So now I have I just cloned repository, and by calling it git show, it is same as git show head. So it shows the detail of the object that is pointed by the head, which is the latest commit. Now let me print out the ID of objects. So I can type git show and any ID, and it will show the detail of the changes in that specific commit. If I want to see what's in readme in that commit, I can do this. And you can see that at that time, there's only 2 lines in readme. And in the current readme, there are several more lines. I can also show a range, for example, between this one and this one. So this is the first commit, then this is the second commit. Another useful command is git list tree. It shows what files, folders are contained in a specific version of repository. It's pretty similar to git show. We can also use pointers or commit ID to show it. Let me show you how. For example, git list tree. Let me show the current repository. You can see that there are so many files here. And for a specific file, in Git, it is viewed as a blob. And for a folder, it is viewed as tree. Now I show the situation in one commit before. It's pretty similar, but without the ttTest.txt file. I can also show everything recursively, even the files inside the folder, by adding -r. You can see all the inside files are also listed out. As we have said, Git has staging area so that we can have the view about what have been changed and choose which changes to keep and which changes to discard before commit them to the repository. And so what should we do if we want to undo some changes here? Git restore can do this thing for us. It can restore the changes in the working directory back to the version in the last environment, in this case, the staging area. And we can also add --staged to restore the changes in the staging area back into the version in last environment, which is the repository, the last commit. We can also add --source to restore a file or the whole repository to a specific version. Let's see how it works. Now I have the remote repository cloned in my machine. And let's see what's inside. Let's say I want to modify this file. Test readme, and you can see that git detect this untracked change. What if I want to undo it back to the version in the last environment, which is the staging area? This is the staging area content. I do git restore readme, and let's see whether it worked. Success. And let's say we have made a change and we have staged the area. So now if we want to undo the staged change, we can use --staged command. Instead of doing this, I can also use some pattern. Let's see. You can see that it's back to the untracked changes. And I can further undo this. Git restore. Now it's completely gone. Now let's try to restore the files into a specific version. Let's try to restore the whole repository. To do that, I'll first see the IDs. So for example, I want to restore it back to this version. Let's first see what's the file difference in these two versions. So this is a file in my working directory now, and let's see the files in that version. We can see that ttTest.txt file is missed in that version. And let's restore our repository to there and see whether it worked. Git restore. We will restore the whole repository. Success. The test file disappeared. Now, if we want to delete all the untracked files in one go without deleting them one by one, we can use git clean command. Because delete untracked files will permanently remove them, So it's better we check what will be deleted before. -n will give us this option. And to force remove them, we can add -f. And -d can remove the whole directory recursively. Let's see how it works. Now I have the new clone repository. If I create a new file, and I want to remove it, let's check what will happen first. In case it said that we would remove the file 1.txt. This is what we want, so let's remove it. And by default, git won't allow us to remove it because it's too dangerous. We must add -f to first remove it. Now it's removed. Finally, we come to branches. Branches in Git is a very famous feature, and it's usually used. Basically, if you're working in a team, you will use it every day. So when you create a new branch, what you are doing is create another copy of the current repository. However, this copy exists at the same time with the original repository. Why should we do this? Because in this way, we can upload different commits to different branches so that different people can work individually on the same repository. So for example, this is our original repository. It's called master. And now if you create another branch, it will lead to a new branch, and you can name it whatever you want. So the commits upload to this branch will lead to the process on this branch. And the process on the master branch is separate from this new feature branch. And finally, you can merge the changes together into one branch. So if you add -d, it will delete the branch name, the branch with the branch name you specify. With letter uppercase D, is very dangerous because it will not give you any warnings. And -m will give you a rename feature. And the -r will list all the remote branches on the remote server. And -a will list all the branches on local server, also remote server. So for example, I've already create a clone repository here. If I want to see all the local branches, I just type git branch. And so now there's only one branch local. So if I want to add another branch, I call git branch, and for example, I name it as bug fix. And now let's run the git branch again. We can see that there are a new branch listed here. However, we're still currently on the main branch. It's marked out by the green color and this mark. So what should I do to switch to this new branch and commit changes to that branch? We can use the git switch function by call git switch, and the function name. We can switch the branch and run it again. We're in the bug fix branch now, so it is also shown here. So now I switch back. If you want to delete a branch, for example, if you want to delete the bug fix branch, just type the name and it said delete the branch. I can also rename any branch. For example, if I want to rename the current branch, I just call -m and the new name, for example, new name, and run it again. It's renamed. I can also rename it back. I can also list all the remote branches. As you can see in the server, there is only one branch that is me, and this header is just the pointer. It points to the main branch. And -a will list all the branches, both locally and remotely. One thing I need to mention is that in the old version of Git, people usually use checkout command to do this switch and other things. However, because it's a little bit confusing, the Git official group has already published this new feature to replace this old command. It will gradually exit the Git command list. So, what if now we have multiple branches and we want to combine them into the single one? Combine all the changes together. Git provides us two choices: git merge and git rebase. People are more familiar with git merge, so I'll talk about this first. But git merge, what it do is it merge a specific branch to the current branch. For example, look at the graph here. If currently you are on the master branch, by calling merge new feature branch, it will actually combine the changes happen on that branch to the current master branch. And one thing you need to notice is before you call merge, you need to make sure that the head pointer, which is your current branch, is what you want. About git rebase, what it does is it resets the basement of the current branch onto another branch. So for example, we're at the new feature branch, and if we call rebase master, it will add the changes happen on new feature branch onto the master branch. So you can see that even though the results are similar, the order are different. And one more thing that git rebase different from git merge is that it can help us have a clearer git log history. I will talk more about this later. So first, how git merge work. Now I will use a new repository as example. First, I call git init. I will do it in a new repository. Let's call it BRAN. So now let's go to this, and it starts from a commit. So here I will going to start a initial commit. I track this file, commit it. It can also be some arbitrary commit. I'll use init commit as an example. So here I use git log a-dog method. It's like all decorate one line graph. And so here you can see that there's only one commit, and head pointer and master pointer all here is like this. And then we create a new branch and switch to the branch. Let's call it test. And then on this test branch, we also do some change and commit it. So add a new line to this file and add and commit it at the same time. So now let's run a-dog again. We can say it's exactly like this. And then let's switch back to the master branch. And at here we do some other commit. For example, I add a master line, a readme file, and commit it at the same time. And run a-dog again. We can see it's same as this. And now what I want to do is I want to merge the changes happen to the test branch onto this master branch. So here I call git merge test. Because I want the new commit happen on the master branch, so I'm staying on the master branch now. By doing this, what will happen is the changes will be combined and create a new commit on the current branch. And finally, it will look like this. However, here you can see that there is some conflict happened because the readme file on these two commits are different, so we need to manually merge it. It cannot auto-merge it for us. So what we do is you can either use the default merge tool of Git, or you use your own IDE to do it. For example, my VS Code. But before that, let's see what happened. By calling git status, you can see that the unmerged path is the readme file. So now I'm going to modify this one. By calling this, I'm open the git VS Code, and you can see that most recent IDE have this user interface. So I either accept the current change or incoming change, or keep both, or comparing them. For example, by clicking that, I have this nice user grid. So let's say we want to keep the post change, and save and close. So now what I should do is add this change and call the git commit to fix this conflict. First add this change, and git commit. And you can see the merge has successfully happened. And let's tell the a-dog log again. You can see that it's exactly like this. And to test your understanding, I have a quick question here. So what if at this state we run git merge master? You can pause the video and think a little bit before continue. So what will happen is that it will end up like this. The changes happen on the master branch will be merged into the test branch and create a new commit here. But after doing this, the latest commit will be on the test branch. So what about rebase? For the first several steps, it's exactly the same as git merge. So I will do them first. First, I create a new repository. Still, you can start from any commit. I will do the initial commit. And the attracted file and the initial commit. And let's run the dog again. One line. You can set exactly like this. And now let's do the other step. Create a test branch, switch to it, and do something. For example, add a new one. And commit and add at the same time. And then let's switch back to the master branch and also do some changes. And commit and add at the same time. And now let's run a-dog. So you can see that it's exactly like this. And then, so what's the difference between rebase and merge is that if we want the new list change happen on the branch of master, we need to call the rebase on the test branch, because what we're doing is reset the basement of the test branch onto this master branch. So now let's first switch to test branch and calling the git rebase. And we're going to rebase this branch on the master branch. So now what will happen is, first the head pointer will go back to the nearest common commit of these two branches, and then go to the latest commit of the master branch. And finally, apply all the changes happen on the test branch one by one onto this newest commit. So because here we only have one commit on the test branch, there's only one reapply. But if we have several, they will be reapplied one by one. So eventually it will be like this. The test branch pointer will also be moved here. And this branch will be removed from the git log history. So what rebase gave us is a really clean history. So if we are working on a large project which lasts for several months or even years, rebase is really necessary from time to time. Otherwise, we may have a really messy and confusing log history, and it's really hard to track back. So here we also need to manually solve the conflict. I will do the same. And I will apply the, for example, incoming changes. And let's run the git status again. You can see we have just modified it. And if we want to solve it, we need to first add this change, and then instead of calling commit, we should call git rebase continue. This is the difference between rebase and merge. So first we add the change, and now we call git rebase continue. I'll tell you why it's different. So as you can see, Git actually pumped this commit message to us. Where is this from? Actually, it's from the last commit of the test branch. As you can see, the details are here, and it's replacing branch test on this commit. So because this is basically what we're doing on the test branch, we add a test line. So I will keep this and don't modify it and just close it. You can see it's successfully rebased. And let's say a dog in history. As you can see, it's all being merged into this one single track. So to test your understanding, I prepared this question for you. What will happen after running this git rebase test command in this state, where the head pointer is pointed at the master branch? I'll give you some time to think about this. You may pause the video. So the answer is, it will be like this. So the last the commit happened on the master branch will disappear, and everything will be happen here. So here comes another question. There's only one branch now. Is it the test branch or the master branch? The answer really depends on your opinion, but most likely people would like to keep the master branch instead of some other branches because, for example, the test branch here most likely is used to add some new feature or fix some bug. So most people maybe choose to keep it as the master branch, but it really depends on you. And another thing I didn't mention is actually if I modify readme instead of keeping both changes or keep the changes from the test commit, if I keep the changes on the master branch, which will make this branch exactly the same as this master branch, actually Git will not add a new commit here. Instead, it will only keep these two commits. This can explain what Git is doing. It's trying to give us a really clean Git log history. You may try this by yourself. So if we are holding our project on a remote server or another computer, what should we do to update the information between our local machine with the remote repository? So Git provides a lot of function for that. For example, Git remote. So what is Git remote? It's like a remote controller which is used to control TVs. So here the Git remote is used to control all the remote repositories. So for each remote repository, we have one Git remote on our local machine. By calling Git remote, we can check all the remote controller on our machine, and -3 will give us more information about them. We can also call the add, rm, or rename in order to add more repository or remove them from local machine or rename them. We can also use git show to show detail about a specific remote repository. And second, git fetch. So git fetch is usually used to try to check what others have done on their computer and make comparison between their version and our version. So what they do is like it will copy the other version of repository to our local machine. However, it's just a temporary store. It won't change our working directory or our stage error or our local repository, none of them. And it's only used to for us to compare it. But of course, we can update our repository and try to merge with that version by calling git merge. However, we don't need to do that. Git provides this git pull function to let us fetch and merge at the same time, or we can use dash rebase to choose the rebase strategy. And how should we update our changes on our local repository to a remote repository? We can use git push. So let me demonstrate how to do that. So first, let me clone a new repository remotely. Okay, let me enter it. And now, if I call git remote, you can see that I only have one remote controller, which is connected with this one. So I can dash away to see more information. This shows the URL of it. One is for the fetch, one is for the push. By default, they're the same. And we can also use git add to add another version of this repository, maybe on another person's local machine. Because I'm only working on this project alone, so I will use another repository to demonstrate it. It's not what people usually do in real life. It's just for demonstration. I can add a shorthand, for example, not used. So now let's check it again. We can see there are two remote controllers. This one is just newly added. If I want to look into more about this one, I can use git remote show not used. It will give us even more detail about that. It's very useful because we can say that the short name of it, we can rename this, the URLs, and which branch we are at, and the detail about the remote branch. So if I want to remove it, I can just git remote remove not used. And now let's check it again. We can see that there's only one origin. So how git fetch work is that, so first I will change this remote repository. For example, I change the readme file by adding this change on remote server. I commit the change. And now our local machine, we can see that it's still not changed yet, and we can call git fetch to fetch the new version of our local machine. However, it won't change our working repository. Let me show you. See, it's still the same. But actually, we can get that by using the pointer called fetch head. This is one we just fetch, and it's just temporarily stored on our local machine. To do that, I can use git diff or main and this fetch head pointer. You can see that there's a new line added in the fetched one. So if I want to update my local repository, I can use git merge fetch head, but instead of doing this, I can just use git pull to do the two things, fetch and merge at the same time. And because I already fetched it, I want to make a new change. Test for git pull. I want to make a new change and update my repository with these two changes at the same time. It's here. So what should I do is I call git pull. And you can see that there are three iterations. And let's compare it with the two versions before. You can see that 2 versions ago, which is before we have made these two changes separately, they don't have these two lines. But now in our local server, we have it. We have these two lines. So now what if I do some changes in our local repository and try to update the remote server? For example, I change the readme. I delete these two lines, save it, and close it. So now you can see that there is a unstaged change. So add the change, and I commit it. And success. And now we push this change to our remote server. Okay, success. Now let's check our remote server. Update it, and they disappear. Success. So there are also many other commands in Git I've only covered those commonly used ones. If you are interested, you are welcome to visit the document for more information. And if you're interested in knowing how to use git stash, I will also put this explanation in the end. So I also prepared a lot of reference here, including some useful graph animation. There are also even interactive playground for you. So you're welcome to check for more. I'll prepare the table of content and the cheat sheet here. Thanks for listening. So in the developing process, sometimes we may need to put down what we're doing now and fix an urgent bug or add in some new features or so on. So Git provides a function called git stash. It can help us save the stage changes as well as on-stage changes temporarily and hide them. So now your working directory will be as clean as before, so that you can work on your new urgency. If you want to also stash the untracked files, it also provides -u function to do the similar things. But however, I recommend using the stash save and add a note message to this stash history, so that in the future you may know which stash you want to restore. And we can also use stash list to list all the stash history, and stash show to show the details, and drop to drop a specific stash history, or clear to clear all this history. And a simple way is to use stash pop to restore the latest stash history. Let's see the status. We can see that there's nothing here, and now I want to create some new files. I create 3 new files, and they're all untracked at this time. Now I want to add the first 2 files. I want to show you all the possible situations. And now I want to further modify this function, this file in the working directory. For example, add a test line to file .txt. And now let's see the status. So we can see there are stage changes, on-stage changes, and untracked files. So what if now I call the git stash function? As I mentioned, it's better to use save and add a message to describe it. Now let's see the status. We can see that apart from the untracked files, all the changes has disappeared because it's currently being stored and hidden from this working directory, and also Git. And now we can use a git stash list to show our records. For example, this is our latest stash, and it's our main branch, and this is our node. And we can also see the detail of it. Stash show stash at 0. We can see that we have added 2 files, and there are 3 iterations because 2 create new file and 1 modification. There's a hidden feature of stash, that is, it will automatically stage your on-stage changes. So actually here, it's already been staged here. We can say that now, for example, I want to pop the latest stash. As you can see, the on-stage changes, the modification change has disappeared because it's already been added here. So after you pop it, it will disappear from the history. Let me stash it again. So here the untracked files is still here. If you want to also hide it, it's still here. You can use git stash -u. And we can see that the untracked file also been hidden. Now let's see the stash list. We can see there are 2 stashes. It's all on the main and all on the same commit object, and it has the same note message. So if we want to delete the arbitrary stash, we can use git stash drop. For example, I want to delete the latest one. And now let's see the list again. There's only 1 left, and let's show it stash at 0. It will show the information of this stash record. And if you want to delete all the stash history, you can use git stash clear. For example, I stash again. For that, I add a new file. And I add it, stash it. And now I stash it. Now let's see the stash history. If you want to delete everything, we just git stash clear. And you can see that all records disappear. And they will not be restored here. So you basically lose your records.